Let's start. So today I'm going to talk about GPT-3 and the PT and the few shot learning. So so a few weeks ago, Changsu shared this paper in Slack, and I found that this seems really interesting because it's about few shot learning, and they say they can outperform GPT-3 using much smaller models on superglue benchmark. And as you know, GPT-3 is one of the hottest thing in this area. So I read this paper, and I wanted to share what I found with you. So the title of this paper is actually from the title of the GPT-3 paper, Language Models Are Few-Shot Learners. And the paper the title is Small Language Models Are Also Few-Shot Learners. So it was really interesting. So it is deeply connected to the GPT-3 and the previous paper from the author, which is introduced the PET training method. So I'm going to go over these three papers today. And first, let's take a look at the GPT-3. So GPT-3 is a huge language model. So the background of the GPT-3 is that, as you guys know, the recent NLP paradigm is fine-tuning a pre-trained language model to a downstream task, and it shows very good performance on many challenging NLP tasks, and it removing the need for task-specific architectures at all. But however, it still needs a large amount of labeled data set for that task-specific, and it needs task-specific fine-tuning as well. But the thing is that humans do not require this kind of large amount of data set to learn something, but a human can do a new task with a tiny number of examples. So the authors of this paper see that point and try to do that. Yeah, this is what my daughter did yesterday, and she just see the first line, and she can feel that empty lines just by see just one example. So this is what human can do. It's kind of one-shot learning. So I just wanted to show this to you. So the two main concepts for GPT-3 is the first one is meta learning. So like I mentioned before, human can learn a new language task by just see few examples. So maybe human can do that, maybe deep learning can do it. So this is called in-context learning. So when we show this kind of few examples to the language model, it can predict the next answer. And the second idea for the GPT-3 is that recent language models shows that a bigger model can do better. So they wanted to test way bigger model can way better. So this is the two main concept for the GPT-3. So the GPT-3 is a huge language model, and the purpose of this model is to do a new task just like the human do. So GPT-3 can pure shot inference without update any parameters. So like this, with the text description and giving a few examples and give the new prompt, and the model can predict the next answer. So this is wholly different from the traditional fine-tuning process. Previously, we are using the examples to update the parameters, even though we doing just few shot learning. So it's basically different from the traditional fine-tuning and the few shot inference from the GPT-3. So the GPT-3 shows the performance. Sure.
How it trains if no parameters are updated?
So this is the language model. So it predicts the next words. It's simple, but the GPT-3 is huge, and it contains a lot of knowledges and common sense. And by training the model like this kind of multi-task meta-learning during the language model pre-training, so it can understand this context and can predict the next word correctly.
Yeah. So my question is, if nothing changes, you just feed the examples, how it can predict after a couple of examples if nothing is changed at all in the model?
Yeah, that that's why like the GPT-2 and GPT-3, has a lot of the attentions. So if you see how GPT models are being trained, that is really simple. So it's basically being trained and for predicting the next word, but that data is really really huge, and the parameters are really huge. So like as we train the BERT and for the mask language model, and so GPT is not about mask language model. They are just simply predicting the next word. The data set is huge, the parameters are huge. Then it's really good for the fine tuning of the every single downstream task, and including like the NER and the classification and etc. So that's what we've seen in GPT-2 and the GPT-3. Basically, like how the model is being trained is actually the same, but the parameters became a lot bigger, and then data became a lot bigger. Then people are amazed in how this simply trained model and can do a lot of different tasks. So that is the one part of the word, and then the other part of the word is saying it doesn't really need to be that big, and then that big model is not really realistic, and then for the being used inside the company, and then not every company can afford and that big size of model, etc. So the paper that the Minu is presenting, like the small language models, also the few shot learners, is located exactly in the opposite word with small parameters and small numbers, and then it can also be a few shot learner.
Okay.
So GPT-3 shows that with only 32 examples, it can outperform the existing BERT, fine-tuned BERT on the superglue benchmark. So it shows how powerful a language model can be, but the drawbacks are, as Chang-Soo mentioned, the model is really, really huge, so it's unusable in real world, most of the cases. And it does not scale more than few examples because we are giving the context for the next word prediction, not updating the model parameters. So that is the limitation. So from these drawbacks, the PT paper is coming. So they are using a relatively small language models like BERT, LBERT, RuBERT, but they are reformulating the downstream tasks to as closed questions with regular gradient-based fine-tuning. So we called pattern exploiting training. For example, like you see here, this is the similarity clarification task. So given these two sentences, the task is to decide these two sentences are entailment or not. So to do that using a mask language model, they are designed this pattern A question mark mask B. So if the two sentences are entailment, the mask word could be yes. So I think this is a clever way to use a language model to do this kind of downstream task. So to do pattern exploiting training, we need patterns for the target task, and the verbalizer. Verbalizer means that mapping the target label to the target word. So with that pattern and the verbalizer, we can fine-tune the language model on the target task. That is pattern exploiting training. And one more interesting about pattern exploiting training is that, for example, for this task, we don't know, we don't have one best pattern for one task. So we don't know which pattern and which verbalizer is good. So we can, they tried several, let me show you. So for example, this kind of data set, they use these 4 types of patterns. And in this case, they use 3 types of patterns and 2 types of verbalizers. So they call this pair a pattern verbalized pair and refer to PVP here. So they use multiple PVPs for one task and ensemble that multiple language models. So let me explain. Let's say we have 3 different PVPs. They train 3 different language models using these 3 PVPs and ensemble these 3 language models to annotate unlabeled data set. By doing that, we can build a much large tag data set, and using that data, we can train one single classifier. So they call this semi-supervised knowledge distillation because previously we have 3 language models, but the knowledge of these 3 language models can be distilled to one single classifier. So they did like this. But this knowledge distillation is not necessary in terms of the performance. So the reason why they doing this is to maintain just one lightweight model. But its performance is not the issue. Using all language models in an ensemble way is shows a little better performance. So they shows which patterns they use for each task. So it's really interesting. So question, answer, ask.
Can you go back to the previous slide?
This one?
Yeah, here. So I actually have one idea. I think that is pretty relevant into the LEB's task. So I think having that language model and then using this language model for each downstream task. Like at the moment we are using still we are using the BERT, but given our specific task, like the cognitive search, is now the core of our business, and I'm thinking about making the language model in which is a lot more specialized for the question answering. And if we think about the language model, that is pretty like the simple, right? The automatically generated data labels, and such as mask language model, and in these closed question cases, it sounds pretty smart, but that is not really the complicated at all. And predicting the next word is pretty simple things. So based on the inspirations of these closed questions, so like think about the question generation, right? And then like we have the questions, and that question can be categorized like like yes no questions, or can I or can't I, when, why, how, right? So like there are pretty 6-7 different types of the questions, and we can categorize that. And if that is yes no question, and we can make like the kind of the closed answers, the closed question answer pairs, is the first thing. And if the question is like the when question, then by using NER, like we just pull some of the time phrases and then can automatically make the pairs and to train this language model. So it doesn't really need to be the correct answer. So for example, if the generated question is, let's say, when do I need to submit this document, right? And then like for training language model, for training this training purpose, and I think like if the answer is something like about time related phrases, like tomorrow or the October the 12th and 2020 or some time phrases, then we can automatically generate this kind of the data pairs and to train the language model. And then if the question is about like the who question, like who needs to control this organization, then also using kind of the general NER, and then we can pull some of the the human names and from the role corpus, and then we can just make it. So a little extension of this close idea, and then we can do the semi-supervised and self-supervised way of the language model, which is a lot more specialized in question answering. So that is the like the one idea that I wanted to discuss with the AI model team. The second thing is, and because the language model is kind of the foundation, and like this is saying about the few shot learning, but if we have the really strong the language model, then using the customer's data into the fine tuning, it also has tons of the business opportunity. And I'm thinking about like, okay, then what else we can have in terms of language model? And so those, the closed questions is a great idea. And one other thing, what I'm thinking is, so there's something that is being used in the image processing. So what they're doing is, and when the image comes in, they like rotate image into the 90 degree, 180 degree, 270 degree, and that label is that degrees like 90, 180, and 270. And being pre-trained, that kind of self-supervised way, and then this the image model is showing a way better performance in terms of the image classification and especially in few chat cases. So if we think about that language model, let's say we just got the text, and so like for example, the various patterns are used in for fine-tuning language models, and then we just assume this order is correct, right? Then in terms of language model, and we can generate like the new text, like patterns various used for fine-tune language model, and for example, and then we just say this is wrong, or we just put the orders of each word because we know the correct answers. And so language model is how we can automatically generate and these the data and label pairs, and then using this data and training the model, right? So those the word orders and also the good examples, and then we can automatically generate. I never tried this one, so I'm not really sure how this language model would be better than mask language model and or like the GPT, like the next word, the prediction. But based on this paper, like how this model, especially PET, is generating those automatic the label and data the pairs, and for training a language model. And this is a lot more the complex and complicated ways. And then with a smaller model, it can have better performance in terms of few-shot learning. So those are the other things, and when, how, what, who kind of the closed question pairs. That is a lot more in advance and than this one. Then I think we can probably have a lot better result in terms of the the question answering these past big language models. So that is kind of the idea. So I think that we can dig into it, and we can, I think, I live in probably can code on that, and we can see the result. Okay, yeah, go ahead.
Yeah, so they used this kind of patterns for each task. And one more idea from that paper is that IPT is iterative PT. The basic idea for behind this is that some parents, the parents are designed by humans just from their ideas. So some parents perform worse than others. So it means that the training set labeled by that parent may be worse than others. So they so the A and B part is I explained here, and they repeated this K times. I mean, from the first few examples, training examples, like 32 examples, we can train 4 different language models if we have 4 parents, and randomly choose 2 of them to generate a soft-labeled next training data set, and training a new generation of language model based on that training set, and doing this K times. And finally, label the whole data set using these K generation language models, and finally train the classifier. So they use this method and showed a little better result than normal path. So finally, they show this result. Compare the few-shot inference results on this whole benchmark, and as you see, PAT shows better results than GPT-3, even though they have much small number of parameters than GPT-3. So this is very interesting. But basically, the difference between these two are GPT-3 don't need any parameter update for few-shot inference, but PAT needs that.
Can you explain like each data set?
Which data set?
Like in the CV, COPA, RTE, these are all different data set, right?
Yeah, I don't know what all of these are for, but I copied these 3 to show the patterns. So the first bool Q is a QA task, and the answer is yes or no. So given passage and question, the answer could be yes or no. So they use these kind of patterns: Q, passage, question Q, answer yes or no. And multi RC is also a QA task. Given passage P and question Q, answer candidate A. They decide this answer is correct or not. So also the verbalizer is yes or no. So I think this is similar to the reader models we are using. And
yeah, I think basically it's pretty much the same, right? The bool IQ, bool IQ, bool Q,
bool Q, yeah, Boolean question.
So BullQ, MRTRC, and what is that data set? From the Google, the one that we have used.
Tidy?
Tidy data set.
Yeah, QIDI, QA.
Yeah. So like those question answers and passages, and these are the essentially all same.
Yeah.
Okay. Yeah. So like hold these the public QA sets. But always English has no problems about data shortage, and so I don't really think they have any other languages and data sets. But out of these, how much are that? Like 2, 4, 6, 8. These 8 data set, and then anything QA related ones, and then we can just write it down and we can use that and then for our training or testing.
Sure. Yeah, so the summary of PAT, one line, small language model is possible to achieve few shot performance similar to GPT-3. So the conclusion of this presentation is that I found that what we are doing, the supervised learning using large amount of label data for task-specific fine-tuning is not the future, but the unsupervised or self or semi-supervised learning with no or few label data, and especially for NLP tasks, using the language model itself, not the label data, is the maybe the future of the NLP. So like we see from what GPT-3 can do, and also T5 can do multiple language tasks, just text in, text out way. And also normal language models can do similar things using this kind of clever patterns. So I feel like all NLP tests are just language modeling. Yeah, that's it for today. And while